Here in Dubai, the sun and wind are often relentless and always the enemies of any structures that are built here. But in a city where top designers are called starchitects, they're even finding ways to tame the harshest forces of nature. In the case of the dynamic tower, the energy of the sun and wind is being harnessed and used to power the building. Impossible as it may sound, the tower will be the world's first building in motion. Set to be completed in 2012, each floor of this 80-story building will hang like a ring around a stationary cement core. The top 10 floors are penthouses, and those residents can control when they move, turning 360 degrees in as little as 90 minutes. The bottom 70 floors are programmed electronically to take advantage of solar energy. To maximize wind power, giant turbine blades will be inserted horizontally in between the floors of the building.
If I have an 80-story building like the one in Dubai, we can have 79 wind turbines, which means a power station.
Each floor rotating independently makes it possible for sun exposure on the roof's solar panels, allowing 100% of its energy to be self-generated.
It's about time, really, that buildings will be self-powered. So this is the solution.
As the sun beats down on this desert city, temperatures can reach 120 degrees, and only 5 inches of rain falls each year. Since the early days of settlement, residents of Dubai have used the harsh elements to their advantage. Take the wind towers that can be found along the Dubai Creek. Here, residents once cooled their homes by draping wet cloths on dowels within the towers.
And when the winds came in, the towers trapped the wind, cooled it through the wet cloth, and then it came down into the residences like some sort of natural air conditioning. The wind towers is an interesting aspect of the cultural heritage of Dubai. It is guided and developed from environmental traditions of the area because of the hot and humid weather.
In 2007, architect Jesse Reiser faced the same challenge with slightly higher stakes. His design? The O14. And where did Reiser go for inspiration for this iconic structure? To the area's Islamic architectural history.
That kind of decorative impulse was also a very functional one. It shaded the buildings from the heat and glare of the sun.
This type of Islamic screen or window is known as jali.
There's a renewed interest in bringing together structure and ornament in buildings. And that was very much a part of the traditional way of designing here.
With traditional skyscrapers, glass windows cover the outside of the building and the structural core is inside. But Dubai's desert environment forced designers and engineers to consider another approach. Their design could be a glimpse into the future of high-rise engineering.
We inverted the process. We pulled all of that material to the outside of the building, and we gained tremendous benefits by doing so. The structure became the sunscreen.
The load-bearing structure of the O14 wall isn't hidden inside the building. It is instead an exoskeleton. The tubular shape makes O14 even more sturdy than traditional high-rises because stress spreads throughout the structure rather than concentrating in the corners. Creating the exoskeleton requires that construction workers painstakingly build the shell one entire floor at a time by pouring cement in between two steel plates. These temporary metal encasements hold in the building's steel reinforcement mesh and circular moldings, which workers eventually hammer out to form holes.
We use a very liquid concrete mix, which is poured from above, and it fills every single void and crevice.
The sand in O14's concrete is much finer than that found in conventional concrete mixture.
We couldn't use concrete that had too much heavy sand. It had to be a super liquid mix in order for the concrete to penetrate all of the intricate spaces that were developed between the holes.
An added benefit of O14's design is a 3-foot gap between the concrete exterior wall and interior glass. The gap creates a chimney effect where hot air enters through the 1,326 holes in the exterior, some of which are 3 stories high, and then rises up past the windows.
This narrow space creates a conduit for the warm air to rise, and the rush of air substantially cools the interior of the building.
The chimney effect, combined with the shade created by the exoskeleton, will reduce the building's cooling costs by 30%. By the time of its completion in spring of 2009, the 22-story O14 will likely be added to the growing list of this city's engineering icons. Dubai is building the world and rules the sky. But can this impossible city defy all laws of nature and bring snow to the desert?